Okay, continuing to look at some basic limits here. Number one, the limit of b as x approaches c is equal to b. B is just a constant, so the limit of a constant as x approaches anything is still going to be that constant. Number two, the limit of x as x approaches c is just the value of c. Number three, the limit of x to the power n as x approaches c is equal to c to the n power. And the fourth one, the limit of the nth root of x is equal to the nth root of c, as long as n is even and c is greater than 0. So n has to be an even root, and we need c to be a positive number. So if we evaluate a couple of these limits here, the limit of x squared, well, that would be equal to 4 squared, which gives us 16. Number two, the limit of 5x as x approaches 4 is the same thing as the limit of 5 as x approaches 4. Times the limit of x as x approaches 4, okay, which is equal to 5 times 4, which gives us 20. So the limit of 5x as x approaches 4 is equal to 20. Number three, the limit of square root of x as x approaches 9 is equal to the square root of 9, which is just 3. Number four, the limit of x cosine x as x approaches pi, well, that's the same thing as the limit of x as x approaches pi times the limit of cosine x as x approaches pi, which would give me pi times cosine of pi, and since cosine of pi is -1, I would end up with negative pi as my solution. Okay. Here are some more properties of limits. Okay. This is our given information here at the top. Given that the limit of f of x as x approaches c is equal to L, and that the limit of g of x as x approaches c is equal to k, we have what's called the scalar multiplier, and we actually just saw that in some of the previous examples. The limit of b times f of x as x approaches c is just the value of b times L. The sum or difference, the limit as x approaches c of f of x plus g of x would be L plus k, and if it's f of x minus g of x, it would be L minus k, the limit of f of x plus or minus the limit of g of x. The product rule, okay, for limits, if I take the limit of the product of the two functions, I just take the product of their limits. Quotient rule, the limit of the quotient of two functions is the quotient of their limits, and notice that k cannot be 0. And the power rule, the limit of f of x raised to the n is the limit L raised to the n power. So, given that the limit of f of x as x approaches 3 is 7, and that the limit of g of x as x approaches 3 is 12, what is the limit as x approaches 3 of f of x minus g of x? Well, that's simply going to be 7 minus 12, or -5. In the second example, the limit of as x approaches 3 of f of x times g of x would be the limit of f of x, which is 7. Change colors here. Times the limit of g of x, which is 12. And that gives us 84. And limits of polynomial and rational functions. Okay, basically for the limits of polynomial functions or rational functions, we're just evaluating the function at the value of c, at the value that x is approaching. So for polynomial functions, the limit as x approaches c of p of x is going to be the value of p of c, the value of the function at c. For a rational function r of x, which is formed by p of x divided by q of x, the limit of r of x, the limit of a rational function, is just going to be p of c divided by q of c. Again, just evaluating that function for the value c. So if we look at the limit of x squared plus x minus 6, that is a polynomial function. So that limit would be negative 1 squared plus negative 1 minus 6. So we have 1 minus 6. So the limit as x approaches negative 1 of x squared plus x minus 6 is negative 6. Okay. Rational function, as x approaches negative 1, I have negative 1 squared plus negative 1 minus 6 over negative 1 plus 3, which gives us negative 6 over 2 and a limit of negative 3. Okay. So some basic definitions of some basic limits, and evaluating some basic limits, evaluating limits of a polynomial, and evaluating limits of rational functions. Okay. So we will do some more problems in class tomorrow. See you then.